Hi, today we're going to talk about managing the design process. In some of our previous lectures we've looked at this process and we've looked at some of the ideas for speccing out a project and developing project requirements. And so we're familiar with this diagram in the lower part of the screen that represents the design cycle. However, if you go from an idea through the design process to a final outcome, as we've talked about, it's not always clear when you start what your final outcome is going to be, and going through this process helps this vision clarify over time. And there are tools available to the person who manages the project, the engineers on the team, that really helps clarify this vision. And we're going to briefly go over a couple of those today. We're certainly not going to cover all of them. Many tools are proprietary to companies, and we're not businessmen or industrial engineers here. But let's talk about some of the more common ones that are used in design. One of these is the functional decomposition or block diagram. Another one is the work breakdown structure, which manages the effort required. Another one we'll talk about manages your most valuable resource, which of course is always time. You find you're always short on time to do things, and that's the Gantt chart. And finally, we'll talk briefly about the role of the project manager as well as a lead engineer on a project. So let's get started with the functional decomposition or block diagram. The really key thing here is the word functional. A block diagram basically breaks down a project into its functional units, and this is an art as well as a science. And so the question we want to ask is, what happens when a device gets too complicated for a detailed schematic or a diagram of all the parts to be easily interpreted? And this device here is from Stanford Research Systems. It's an electronic device called a lock-in amplifier. It's an analog device, and it's actually fairly old. I have it in my laboratory, and at times I've had to go in and repair things or really figure out how it works. So I downloaded the product manual, and I really couldn't show you a schematic because it's on multiple pages and far too complicated. But what you see here probably on your video screen is a gray blur, but to me is a list of components, is about 150 of the 1,148 components in this electronic instrument. And certainly with over 1,000 components, you can't look at a diagram and understand in any way how this works, because the human mind just can't keep this much information in its head. So what do? How do we get a holistic understanding or an overview of how this device works? And we need this if we're eventually going to design something. Well, the way we do this is through the block diagram or functional decomposition. And this is the block diagram of the analog lock-in amplifier that's downloaded from the manual. It's complicated looking, but it's not nearly as complicated looking as if there were 1,148 different components here. And if you look at this and really examine this for an hour or two, you can understand with a basic knowledge of electrical engineering how a lock-in amplifier really functions. This is a beautiful example of a block diagram. So let's look at some of the features of this. First of all, every block on this page describes a function. This one happens to be something called an input discriminator. But each one of these symbols represents a different functional part, not components, not physical layout on the board necessarily, but a function. And that's the real key to understanding what a block diagram is. Block diagrams, if they're good, use standardized symbol. Here the triangle represents amplification, and this circle with an X in it represents a device called a multiplier. The lines on the block diagrams, and it's a little hard to see probably, but these are arrows, show the flow of power, data, signals. Anything that moves through here shows and is shown by a line, and the lines really show how this information or power signals will move through a system from part to part and get acted on by each part of the system. A good block diagram like this one has additional information which provides clarity. There are some figures here and some graphs that really show how this works, so you can understand it just by looking at this diagram. And finally, a block diagram clearly indicates the system's inputs and outputs. Here are some of them that I've highlighted in purple. So when you look at this block diagram, an engineer will know what they're putting in and they'll know what they're getting out. And the block diagram really helps you in the design process to get a mental representation of what it is you have to build. If it's complicated at all without a block diagram, you will not be able to build it. Block diagrams evolve over the life of a project, and the rate of change of your block diagram, the exploratory phase, when you're starting to explore the parameter space, block out the solution space and see what solutions are, they should change very quickly. But the rate of change should slow to practically nothing about halfway through a project, because otherwise you can't build something that's continually evolving. And here's some examples of a first block diagram by one of the teams in the design class I teach. This is version 1.0. And over time, by the end of the project, we'll see what the block diagram looks like in a minute. So let's fade that one out and fade the new one in. This is a fairly nice block diagram. You notice the block diagram has gotten a little bit more complicated. You'll notice there's more information describing what things are. One of the nice things they did is they've coded the blocks by who's responsible for them. And so they have a little color coding scheme down here as well. They're also using different symbols for RF communication via wired communication. So really, the more detail you put in a block diagram up to a point, it really helps your reader. The next tool I want to talk about is the work breakdown structure. Now, while a block diagram helps you determine how you're going to build a system, the work breakdown structure is used to help you determine what effort is required to complete the design process. So let's look at an example that I've downloaded from Wikipedia. This is a work breakdown structure of building a bicycle if you went to a bicycle shop and bought components. And the hyperlink, if you want to take a look at work breakdown structures in more detail yourself, is down here. We see a couple things with this work breakdown structure. It has different levels. We've got a level 1, a level 2, and a level 3. And as we go deeper into the levels, levels 2 is more complex than level 1 and gives more detail. Level 3 gives more detail than level 2. We also notice that the total amount of work in terms of relative terms is always given as 100%. So to build a bicycle, it requires 100% of our effort. We then break building that bicycle down into parts, the frame set, the crankset, the wheels, etc., etc. And this total also comes up to 100%. But let's take a look at something else. This part of our work breakdown structure, the frame set, the crankset, the wheels, the brakes, the shifters, probably correspond very, very closely to the block diagram of a bicycle. But also on the work breakdown structure here, there are some things that don't correspond to actual functions of a bicycle, the integration, the project management. These are things that take effort, but are not part of the function of the bicycle. And then in the next stage, we break each of these things down into the next level. You'll notice here we have detailed numbers talking about the overall percentage of effort required to put the bicycle together. You'll notice that overall, building the rear wheel and testing the bicycle are going to require much more effort than anything else, but we also notice always we sum to 100% effort. So your work breakdown structure really is a way that helps you determine how much time you're going to put into things, what the potential time sinks are, how to allocate time, identify where some bottlenecks in the design process might be, and it also gives you a holistic perspective of the work required and integrates very, very closely with the block diagram that should be the first step in understanding and outlining your design.